Okay, we're going to finish up a little bit of the Mesozoic era. We're going to finish up with the Cretaceous period. So we talked about the Triassic and the Jurassic, and now on to the Cretaceous. And then we'll move on to the Cenozoic era. So this was the last period in which the dinosaurs actually lived. Dinosaurs continued to diversify. They became herbivores, and ornithischians became more dominant, okay, which is kind of a big deal. First flowering plants came about, so it's like up until this time period there were no flowers, no flowering plants. And then of course this Mesozoic era ends with a huge mass extinction. That was about 66 million years ago. So some of the Cretaceous plants were, again, like we talked about the flowered plants, the rapid appearance was just huge. It was like this explosion of flowering plants. They appeared about the same time as the number of insects increased. Go figure. Pollination, more plants, flowering plants. So, kind of makes sense. So, could insects have helped the flowering plants evolve? Absolutely. I mean, insects are one of the main ways that flowering plants are pollinated. So, kind of a cool little, thing to think about. Okay, so here goes another extinction. So we talk about extinctions all the time. The Great Cretaceous Mass Extinction. 65 million years ago, nearly 80% of all life on Earth was wiped out. That's a lot. Not just the marine life, but all life in general, okay? Wiped out in an incredibly short period of time. Bam, done. A lot of people think it could have been a huge meteor that destroyed a lot of the life, but also changed the climate. Approximately 60% of all species went extinct, affected many land animals and plants, and affected fewer marine animals. So actually, out of the 80% of the wildlife, or the life that was wiped out, most of that 20% were marine animals that is still survived this mass extinction. Okay? So what caused the mass extinction? You're going to have lots of different theories out there about what happened. So a couple of things are the meteorite impact theory. So that people believe 66 million years ago, approximately a 10-kilometer wide meteorite, which is pretty huge, struck the Earth near what is Mexico. Okay? I love this, by the way. It says, oh crap, that was today, and the dinosaurs left, and there's the ark. But nonetheless, that is one of the main theories that basically talks about why things went extinct and this mass extinction occurred. Okay? So what animals survived? Let's talk about the mammals, birds. Okay, a lot of mammals and birds survived. Birds, being up in the air, weren't quite as affected by this, whatever it was, whether it was a meteorite or the climate change or whatever. But those seemed to survive. Mammals became a lot more adapted to extreme conditions. Many plants, so ferns were the most successful plant. Trees and flowers existed still. Small lizards, crocodiles, alligators, turtles, and then a lot of the fish, squid, and sharks survived. Okay. How could a meteorite impact cause a mass extinction? So I'm going to read through these couple of things. I want you guys to keep this in mind. The impact could have caused shock waves, tidal waves, sent tremendous amount of dust into the atmosphere. And then as the dust re-entered the Earth's atmosphere, it would instantly have heated the atmosphere, causing tremendous forest fires. Kind of interesting to think about that, right? The dust could have caused the Earth's climate to cool down in the long run by blocking the sunlight. Okay, so that's kind of interesting that so much dust in the air can kind of block that sunlight, and all of a sudden you have this huge climate change. Plants and animals went extinct due to climate changes, competition between organisms, so that's why only certain ones still remained after that. Okay, so there's some evidence for the meteorite impact. Unique quartz crystals are found, kind of like when you see some of those rock layers, like take for instance in the Grand Canyon where you have all those layers of rocks and they really tell actually a story about what happened, where you have these unique quartz crystals that are found in this one layer. Very common, formed under high pressure and temperature. Okay, so think if there's a meteorite and there's a lot of pressure and a temperature change, you have this layer of quartz crystal that all of a sudden has been laid down. Well, this quartz crystal is only found in meteorite craters and nuclear testing sites. And think about it, all the stuff under here, maybe fossils that are found, are things that no longer exist and are extinct now, okay? Or any fossils that lay above the quartz crystal now still exist. So those things, came about after. So this thin whitish line, which is the quartz crystal, so again, lots of dinosaur fossils were below this line. No dinosaur fossils were found above that line. So that's a big kind of evidence part for the meteorites hitting the Earth and then causing a mass extinction. Evidence number 2, iridium. So this is an element that's very rare in Earth rocks, very common in meteorites. The layer of rocks above the last dinosaur bones contains approximately 160 times normal level of iridium. Okay, so again, iridium found in meteorites. If you find that kind of near those fossils with that time period, that would be some good evidence, right? So problems with the meteor impact hypothesis. Why were some animals affected while others were not? That's a question that is constantly being battled. Why did birds survive and dinosaurs, a very close relative, did not? Why did small reptiles survive when small dinosaurs didn't? Why did mammals survive? So again, we could kind of speculate as to why certain creatures, basically made it through that mass extinction, but it's kind of interesting to think, have no idea. So, things to think about. All right, moving on to the Cenozoic. We're going to breeze through this, and then we'll be moving on to the next unit. So the Cenozoic Era, we call the era of recent life. Okay, this encompasses the past 65 million years of Earth's history, which still seems like an incredibly long period of time, but we know so much about this because it's the most recent. So formation of the polar ice caps, both in the northern and the southern hemispheres. Modern mountain ranges started to develop in the Cenozoic era, so the mountain range that we know so well, the Rocky Mountains, okay, and they assumed their current positions as they are now, right? All right, during this time span, the physical landscapes and life forms of our modern world, so what we see today, started developing 65 million years ago. The Cenozoic era is shorter than all the other eras, but it possesses a very rich history because we're able to basically put the pieces together a lot easier than some of the older time periods. The Cenozoic era is divided into 2 periods of very unequal durations. We call it the Tertiary period, which is 63 million years long, and then the Quaternary period, which is only 2 million years. Okay? Kind of weird that so much of the Cenozoic era belongs to that Tertiary period. Okay? Dramatic changes in climate. We had at times continental ice sheets that covered a third of the Earth. Various species became extinct due to those, ice ages type things. Mammals become the dominant life form. We call this the age of mammals. Woohoo! Go mammals! Okay, so more on the Cenozoic. So it's divided into 2 periods. The Tertiary, which is the time before the last ice age, and the Quaternary, which includes the present. And then it's divided into epochs, okay? So we're going to talk a little bit about these epochs here, but you have this entire thing as the Cenozoic era, and then you broke this up into the Tertiary and then the Quaternary, okay? So see how big the Tertiary is compared to that. And then we'll talk about some of these epochs. Mountain building. So erosion wore down the Rocky Mountains, but uplift continued. Volcanism returned at the end of the Eocene, so you have more volcanoes and active volcanoes. So a little bit about the formation of the Rocky Mountains, since we do live here. This is during the Cretaceous period. During the breakup of Pangaea, the Pacific plate subducted, so it goes under this North American plate and causes this kind of lift up in the land. So that's what built up the Rocky Mountains. Kind of cool. A lot more detail go into that, but we won't take that much time in that. But if you're interested, go check that out. Go research that more. It's kind of cool to see the evidence of what's happened, because obviously we live by it. So the final breakup of Pangaea, some continents separated while others collided. So you had some of this separation and then others collide, and you get what we have today. So Africa was colliding with Eurasia, which built the Alps. Remnants can be found in 4 bodies of water in Europe. India crashed into Asia to form the Himalayan mountains. So it's kind of cool. Here's just a quick little picture. You have these 2 plates that kind of come crashing together. Well, when you crash together, something has to give, and that's what happens, is you have the formation of mountains. Okay? Tectonic forces. So scientists think that Earth is relatively in a warm phase right now. Future climates could become colder, which is interesting because a lot of times when you look at the patterns of temperatures over even just the last decade, I can't really see a trend in us getting colder. Sometimes it seems like it gets hotter. So it just depends. But over a long time period, many scientists do think that our climate will get much colder. Tectonic forces continue to shape the Earth. In about 250 million years, tectonic forces will largely eliminate the Atlantic Ocean and once again form a supercontinent. Interesting. Don't think I'll be around for that, 250 million years, but interesting to think about. Okay, so let's talk about some of these epochs, the Paleocene and the Eocene. This is where modern plant species in much warmer climates existed. We call this the thermal maximum. Okay? Modern mammals began to evolve by the Eocene epoch. They were much smaller in size. So you have some of these huge mammals that kind of existed at the beginning of the Cenozoic era, and then they become a little bit smaller in size. They just, whether that's survival of the fittest or, things weren't necessary, they didn't have to be huge, and things started evolving and basically, kind of becoming smaller mammals. In the Oligocene epoch, we have the climate continued to get drier and cooler. So first it started off pretty warm and moist. Now it's getting drier and cooler. Favored the growth of grasses and cone-bearing hardwood trees. Earlier types of mammals became extinct. Larger species started to flourish. So you have this constant up and down of what kind of species are going to flourish at this time period. So during the Oligocene, now all of a sudden you have larger species that are flourishing. Maybe due to competition or survival of the fittest. Again, it's going to constantly do this up and down of, you might have smaller species at one time that are flourishing versus the larger. So things such as deer, pigs, horses, camels, cats, dogs, all those things began to flourish in the Oligocene. Now they might have looked a little bit different than what we've seen today, just based on a little bit of the evolution of these animals and how they can kind of undergo these microevolutionary changes, okay, due to climate changes, what their land looked like, and so forth. The Miocene epoch, birds and mammals began to look a little bit more modern. Tons of apes evolved, okay? Climates warmed up again, ice caps began to melt, oceans flooded North America. You have a trend reversed in the middle of the Miocene, okay? Set stage for ice ages. So all of a sudden you have this warmth at the very beginning, and then in the middle of the Miocene, you have this crazy cooling down, and the ice age begins, okay? So, or should I say, it sets the stage for it. Kind of crazy how quickly, not that it's quickly, because this is still over millions of years, but still you have these climate changes that are drastic. So here's the Ice Age, part of the Pliocene epoch. So the late Pliocene and the early Pleistocene, you have these ice ages. Ice covered much of the northern hemisphere. So if you see that, look at that huge just sheet of ice. Glaciers advanced and retreated at least 4 times. Ohio and Missouri rivers marked the southernmost point of the glaciers, and glaciers carved out lakes and valleys that we see today, which is kind of cool to think about, okay? All right, let's talk a little bit more about the Ice Age. I think it's kind of cool, especially if you guys have seen the Ice Age movies. There's a lot of truth to those. So the climate began to cool, and new animals evolved. You have the mammoth, the saber-toothed cat, modern humans, so those we're called the Homo sapiens. But it's pretty cool that these are the basically the species that were able to survive the Ice Age. There's more than just what I mentioned. Several periods of glaciations. Animals had special characteristics that allowed them to endure the cold. Lots of thick fur. Other animals moved to warmer regions. Okay, less adaptable species became extinct. Fossils of early ancestors of humans appeared, hunters, which led to extinction of many large mammals. So, us as humans existed, and basically we would hunt some of these animals and they would become extinct because of that. But, they were hunted to eat, okay? All right, so let's talk a little bit about humans. First, bipedal, meaning they stand on 2 legs. Human-like primates appeared about 6 million years ago during the late Miocene. Earliest modern humans appeared about 195,000 years ago. Migration was definitely influenced by the Ice Age. So you have all these huge sheets of ice, and migration of the humans kind of was dictated by these ice ages and where the Ice Age was hitting hard. The Bering Strait was exposed, and humans likely walked across to North America. Now these again are all kind of theories. They have been studied, but this is what is going to be taught in your lesson. And not to say that you can't go and do some extra research and find out more stuff that happened and other theories about how humans came about. Also, again, this kind of plays a part in the whole evolution thing. If you believe in and you have a strong faith, then maybe some of this might confuse you. So I really want you guys to make sure that you guys do your own research. Come up with some of your thoughts. This is what's taught in your text, but there are many theories out there, and I don't want to discount some of them, okay? So the Holocene epoch includes the present day, okay? Began when last ice age ended. As ice sheets began to melt, the seas began to rose, the coastlines took shape, Okay, and what we have today is kind of after that last ice age. The Great Lakes formed, modern humans developed agriculture and began to make tools and really become a little bit more kind of well-versed in just living in general. Okay, super funny picture I found. I thought this was awesome. It says, the anatomy of an urban thug. Okay, so some more evolution. I found this picture. I thought this was hilarious. So, anyways, hopefully you laugh at it like I did. Okay, bringing it all together, I'm going to show you guys a video that basically brings about everything. It's a little cheesy, but nonetheless, it works. Okay, here you go. Okay, we're having some difficulties here. Move it on. Okay, I will post this link for you guys to watch where you see this link, because sometimes I have some difficulties with my YouTube videos. Okay, alright, so we have finished the last bit of Unit 1, so we'll see you back for Unit 2.